Okay, so up at the top here is the sum that we found, 2/3 plus 4/9 plus 6/27 plus 8 over 81 plus 10 over 243. Then n of that just means tell me the number, like as a decimal.
Yeah.
And then we did a little for loop that just does the sum, the first 10 terms of the sum. So let's see what we got. Oops. We got a little error. There we go.
So 1 point, looks like
1.47.
1.47 from our original sum, and then our second sum down here. I forgot to say what it was. 1.499 for the first 10 terms. Maybe I'll try 20 terms.
alright. Ooh, 1.5.
It's already rounding to 1.5.
Huh. So
What do you think if I do 30 terms?
So think it would stay 1.5.
Why?
Because the
it's
things you're adding on are so tiny.
so small.
Yeah, they're so small. We're already divided by 3 to the 20th there. So yeah, 1.5.
So yeah.
So it looks like it does converge to 1.5.
Okay, so what I want to do is I want to close this window. And behind it should be the other mathematical window, which is where... Here we go. Alright, so here's my just a little tiny computer program I wrote to
Alright.
do this. So we're going to count the valid rolls until we get a 6. That's what count 1 is.
Alright.
Count 2 counts the number of rolls with only even numbers.
Alright.
Okay, so if we went, remember when we were doing, we had a lot of fails, so I'm just making sure I count only the ones that had even numbers.
Alright.
I'm keeping track of the maxes, the max of number of rolls before we get kicked out, before we get an odd number, and the max until we get a 6. And then we'll do 100,000 runs.
Alright.
Because we did, what did we do? Well, we found 12 ones, but I don't know how many that was. And then here's just the code that goes through. So I'm going to loop the number of max runs. I'm going to roll the dice 1,000 times, figuring I'm going to get a 6 eventually, right?
Yep.
So then I just choose a random number from a random integer from 1 to 6. That's what this random real gives you, a number between 0 and 1. I multiply it by 6, add 1, and then round down to the nearest integer. That's what floor means.
Alright.
If mod A2 equals 1, what is that asking?
So if the number mod 2 is 1, then
What happened if the number mod 2 is 1?
well then it is an odd number.
So what do I do?
You have to do it again.
Okay, so then the way I cheat here is I just set I to 1,000 in our loop. And just that exits the loop, essentially. If the number is mod 2 is 0, what's that saying?
So it's even.
Okay, now if it's 6, what do I do?
Then you increase the count. Increase both counts.
Okay, I increase the count 1 is counting the number of rolls it took. So I add I, that's how many rolls it took. Count 2 is the number of valid trials we got. So I add 1 to that.
Alright.
Then I just check on the maximum. If I'm bigger than if I is bigger than the maximum it took, then I'm just counting the maximum. Set it equal that, and then I cheat out of the loop again. I set I to be 1,000. Okay, so here's 100,000 runs. You ready?
Yeah.
All right. So I think I got to go down to the bottom here, and I'll zoom in. So we saw 37,334 total rolls in the valid rolls out of 24,000 valid rolls. So roughly a quarter of our rolls became valid rolls. Only, and the average was 1.5.
Alright.
The longest we went before getting kicked out by an odd number was 12,
Wow.
Ooh.
and the longest we went before finding a 6 with only even numbers is 9. Okay.
Okay.
So I'm going to change it to 1,000,000 rolls now, just and rerun it,
Alright.
because I can run that on the fly. I think anyway. Is it running?
Yep.
Yeah, there we go. All right, so 376,000 total sums out of 250,000 rolls. So how many of our rolls what percent of our rolls were good, roughly?
So it's still roughly a quarter of them.
Yeah, 250,383 rolls out of 1,000,000 were valid.
Yeah.
The average is 1.5. 13 rolls was the longest until we got kicked out by an odd number, and 11 was the longest until we found a 6. So overall, what seems to be happening when we play this game?
So we seem to get roughly about a quarter of our rolls work.
Okay.
And it seems like there are a couple high ones, like the 11.
Mm-hmm.
But my guess is that most of them are probably going to be, because of the 1.5, most of them are going to be around 1, 2, and the occasional 3.
Uh-huh. So what is this condition of saying that you only got even numbers do to your rolls
Well,
Well,
until you find a 6?
I guess it decreases the expected value, because normally the expected value would be 3
Yeah.
to find the 6.
Uh-huh.
So it basically cuts it in half.
Right. So it's not obvious when you read the problem that this is going to cause such a drastic change,
but it does.
but it does. And that's what makes this a really nice conditional probability problem. It's surprising what a difference
Yeah.
this makes.
Yeah.
And it's surprising, and remember back to the beginning when we saw in the blog where like 60% of the people guessed it was going to be 3,
But it's not.
and it's 1.5. So this is a really surprising result. And I think the most important point to learn from this problem is that when you have these conditional probability problems, they can really be sneaky. The answer
Yeah.
can change by a lot, and it doesn't seem like that's going to happen.
Yeah.
All right, what do you guys think of this?
Pretty cool.
Really, really neat problem.
All right, good work, guys.